Number 3, we've got an initial value problem. And so when I look at this, I can see that this is first order and it's linear. This one's also separable. If you bring this 3x squared y to the other side and factor out the x squared, you can separate it. I'm going to solve it as a first order linear, but it is your option. You should get the same result either way. So if I do it as first order linear, remember the first thing I need to do is find the integrating factor, which is e to the integral of that coefficient on y, because there is a 1 coefficient on the y prime. Remember, if there wasn't, I'd have to get that first. So I just have to integrate this 3x squared. That's going to be x cubed over 3, canceling out. You get e to the x cubed as your integrating factor. So I'll multiply through this equation by that. I get e to the x cubed times y prime. That's a cube. Plus, I'll go ahead and put 3x squared, e to the x cubed, y equals 9x squared, e to the x cubed. This side, you can check, this is going to be derivative of the product of my integrating factor with my y. You can check. Derivative of y is, oops, lost my y prime. Derivative of y is y prime times e to the x cubed. Derivative of e to the x cubed is derivative of e to the x, which is e to the x. Put the x cubed back in, and then here's the derivative of x cubed. And then this side is, well, nothing. I haven't done anything to this side yet. But now I need to integrate both sides. And the one on this left-hand side is set up nicely because that product rule will just go away, or this derivative will just go away. Over here I've got the integral of 9x squared e to the x cubed. So like I said, this one's easy. E to the x cubed y is what you get. This one, you can do a substitution for that exponent because du is 3x squared dx. And so u will go here, and then I still have a 9x squared dx. Well, if I want to make this 9, this I can multiply through by 3 to get 9x squared dx, and that will replace 3 du will replace that. So this is going to be the integral of e to the u times 3 du. And now I can integrate that because integral of e to the u is e to the u, so I end up with just 3 e to the u plus a constant. That is, I have e to the x cubed y equals 3, putting my x cubed back in, 3e to the x cubed plus constant. And I'll go ahead and use my initial condition right now to figure out my constant. I'll plug in 0 for x and 1 for y. So this is going to be e to the 0 times 1 equals 3e to the 0 plus c. Well, that's going to give me 1, and this is going to give me 3. So my constant is -2. Alright, so putting that back in, I get e to the x cubed times y equals 3e to the x cubed minus 2. And then I need to get rid of this e to the x cubed, and I'll do that by multiplying through or dividing by e to the x cubed, if you want to say it that way. That's probably the easiest way to do it. Just say divide by e to the x cubed on both sides. That means every term. So my final answer, canceling out here, you get y. Canceling out here, you get 3, and then just leave it in the denominator there, or you can write it as e to the minus x cubed if you like, but account for it being in the denominator one way or another. So that would be your final solution for that equation. And like I said, if you had done it by separating at the beginning, you should still get to the same point.